This is cover test, refractive error and interactions with eye position for V551 ocular motility and refraction. Refractive error has an interaction with our cover test findings, specifically making patients more ESO or more EXO, depending on the type of refractive error they have. This is done through a neural pathway link between accommodation and vergence. Here's a schematic of how the eyes respond neurally to different blur as well as different convergence systems. I generally don't terribly care for this figure, but I think your BV professors probably dream about this every night when they go to bed and think about it when they wake up in every morning. The critical component, though, of it is that right here there's an interaction. Whereas we have more accommodation, we get more convergence, and conversely, as we have more convergence, we get more accommodation. Now, this system works out well when everything's aligned, when we're perfectly focused, and when our eyes are aligned well. If one of those two things, though, go out of alignment or out of focus, we now have a problem where there's a disagreement within the system. Let's think about hyperopes, for example. Hyperopes need to accommodate just to see at distance, and they need to accommodate even more at near. And this is because they do not have enough optical power from the cornea and the lens to put the image on the retina. Well, what happens in our neural pathway as we do that? As we increase our accommodation, we get a signal to convergence to converge even further and more as we increase our accommodation, which is not helpful when the eyes are already aligned to try and converge more. Let's watch how that happens as we have increasing accommodative demand. We first start out aligned, but as we accommodate more and slower bigger steps, we actually start to converge the eyes more and more, up to a point where the eyes can no longer take the system, and we have a breakdown. Conversely, with myopes, we have way too much power. So they don't need to accommodate really at all till the near target demand is greater than their prescription. Due to this, there's no input from the accommodation into the convergence system until we've passed their actual prescription. And sometimes there's actually negative input if we have way too much myopia compared to our accommodative needs. Well, let's take another look at that. In this case, even though there's accommodative demand increasing because of our refractive error, our myopia, we have actually negative input or no input for a while until we exceed that person's prescription, and only then do we start to converge. So we'll have less convergence because of our myopia. Our take-home points from this are hyperopes are far more likely to have ESO positions at distance and even more ESO at near. Conversely, myopes are more likely to have an ortho position at distance and more EXO at near. Thank you.